Memory safety. All right, so been talking for the last lecture or two about memory safety, buffer overruns, and some more vulnerabilities. How do we defend against these vulnerabilities? How do we mitigate or eliminate these risks? Broadly speaking, there's three common kind of techniques you'll see out there. One technique we've already discussed, use a memory safe language. Use a language like Java or Python or some other language that does all the bounds checking for you. The compiler inserts all the necessary bounds checks. Then buffer overruns simply can't happen no matter how many mistakes you make in your code. Great solution if you can do it. For instance, if you're writing new code, you have a new project, you're starting afresh, use a memory safe language is often a good idea. Approach number two, let's say you can't use a memory safe language or you don't want to, or you've got some existing code or you don't have the choice, and you're going to use a non-memory safe language like C or C++. Then what you need to do is you need to insert into your code bounds checks. Before you go write to memory, check to make sure that that's in bounds for the array or the object you're writing to. And then the third approach is if you're using a non-memory safe language. Alternatively, and this you would typically use this if you had some existing code that wasn't written following either of the first two approaches, then there are some operating system or compiler level techniques you can use to harden the code to make common exploits harder. And this is kind of not a guarantee, and as we'll see when we talk about it, it's got weaknesses and it's often bypassable, so it might not be your first choice. If you can go with either of the other two options, they're probably a stronger defense, but you can't always go with them.